Alright, this video covers Trig Notes 2.3 or Pre-Calc Notes 5.3. What we're going to be doing today is working with trig equations, and we're going to figure out how to solve them. We're going to use the same process as if this was didn't have the trig function in it. The original goal when we're solving equations is to get the x by itself, and so that's what we're going to do with this problem. But instead of our answer being equal to just a number, what our answers are going to be are some angles that will work for this problem. So what this problem is asking us is 2 times the sine of some angle minus 1 is going to equal 0. Again, if our original goal is to figure out what x is, let's get the x by itself. We'll do that by getting it alone by moving the 1 over first, then moving the 2 over. So I got the sine of x equals 1/2. And again, if I want to move the sine over, because my goal is to get the x by itself, I take the inverse. So it'd be the sine inverse of 1/2. So remember, when you're taking the sine inverse, you're asking for what angles have a sine equal to 1/2. And that's where the unit circle is going to be very handy. What angles have a sine of 1/2? So let's start here at 0 and work our way around. Sine is the y values. So notice right here I've got a 1/2. So 30 degrees, or pi over 6, we want to give it in radians. Pay attention to what your problem asks. Sometimes it will ask for degrees, sometimes it will ask for radians. I'm going to show you both so you can see it done both ways. Keep going around the unit circle. Let's see. Here's another angle right here. 150 degrees. And 5 pi over 6, which is the same thing, if I want to give it in radians instead. Keep going around the unit circle. That's a negative 1/2 for sine. That's a negative 1/2. So on my unit circle, I get these two angles. But those are not the only two angles that have a sine of 1/2. If I keep going around, if this is 360, I go back to here. Wouldn't 390 degrees, if I add 360 plus 30, give me a sine of 1/2? And keep going here and add 150 to 360, so 510 degrees should also give me a sine of 1/2, and I could keep going and keep going and keep going. So I can't possibly list out every single answer. So the way that we do it, instead of just writing 30 degrees and 150 degrees, is we would write 30 degrees plus n 360, 150 degrees plus n 360. So what that means is you take 30 degrees, you add any multiple, that's what the n stands for, of 360 to that. Or 150 degrees, add any multiple of 360 to that, and you're going to find all these coterminal angles. If you want to give the answer in radians, you would say pi over 6 plus n 2 pi, and 5 pi over 6 plus n 2 pi. So what we're saying here is pi over 6 works, but if I add 2 pi, which is the equivalence of 360 to that, I'll get an angle. If I take 5 pi over 6 and I add 2 pi to that, I'll keep getting all of the coterminal angles that work. So now you don't have to list out both of these answers. Just pay attention to whether your problem says give your answers in degrees or in radians. I believe the book is giving the answers in radians, so it's going to be important that you know how to do this. But just pay attention to what the problem asks. One thing also to do is you can check these. You would want to check these by making sure your calculator, if we're in degree mode, plug it into your calculator. You type in 2 sine of 30 degrees minus 1, and that should equal 0 in your calculator. If it does, then you know this angle has worked. Again, you need your calculator to be in degree mode when you do that. Again, do it for the other one. 2 sine of 150 degrees minus 1, that should equal 0. And again, you'll find that both of these will check out if you put it in your calculator. And it's in the right mode. If you were to check these in the calculator, you would just change these to pi over 6 and 5 pi over 6. But then you'd want your calculator to be in radian mode. Alright, next problem says solve for x, so find all the angles that work here. So let's get the x by itself by getting rid of the 2 first. So cosecant squared of x is equal to 2. Let's get rid of the squared. Take the square root. So cosecant of x is equal to plus or minus the square root of 2. Remember, whenever we're solving equations, we want to consider, when dealing with a radical, the plus and the minus. Now here's the problem that I run into. Cosecant, not on my unit circle. Remember, this is a cosine, comma, sine value. But I do know that the reciprocal of the cosecant is the sine. So if I take the reciprocal of this side, I gotta take the reciprocal of this side also. Well, the reciprocal of plus or minus the square root of 2 would be plus or minus 1 over the square root of 2. Now, this is not on my unit circle, 1 over the square root of 2. But if I rationalize it, I end up getting plus or minus square root of 2 over 2. And so that's really what I'm looking for now. So if I solve for sine, I want to move the sign away. I'm looking for angles that have either a positive or a negative square root of 2 as their sine value. So if we go through and we look at our unit circle, square root of 2 for the sine would be 45 degrees. It could be 135 degrees. It could be 225 degrees. And then finally it could be 315 degrees. Now, but again, those are just one time around the unit circle. I'd want to give all of their coterminal angles as well. So I'd want to say plus n360, plus n360, plus n360. Or another thing that I could do is I can recognize that these happen because they're 45 degrees. They happen to all be 90 degrees apart from each other because they're multiples of 45. So the difference between here and here is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. I could really just list out my first one. I could write it as 45 degrees plus some multiple of 90 degrees if I wanted. Your book is going to write it like this. They're going to give you the answers as 45 degrees plus some multiple of 90. And you may be saying to yourself, well, I didn't get that. I got 45, 135, 225, and 315. This is the shortcut. This is so you don't have to list all of these. Now, this will only be, you'll only be able to do this if you find that the distance between all of these is the same. 90 degrees, 90 degrees, 90 degrees, and 90 degrees. And just so happens for this one it is. If you wanted to give these answers in radians, you would write it as, instead of 45 degrees plus n pi, it would be pi over 4. Let me do that in a different color. Pi over 4 plus n pi over 2. So these would be your two different answers. Could you leave your answer like you listed right here? Absolutely. It's just a lot more angles that you have to include. And they're all saying the same thing. It's just I'm writing a lot more here. And I'm going to notice, or what I have noticed in the past, I should say, is that this is the way students will tend to write those answers. Recognize that all three of these answers are saying the same thing. Okay? But your book is probably going to give it to you in this form here, or this form if it's in degrees, versus listing out all of the angles and then saying what their coterminal angles would be with that. One thing I didn't mention before I changed the screen was we should check this. So if we're going to check this in the calculator, because we can't actually type in the cosecant squared, what we'd want to do is we want to type in the sine of, if 45 degrees was the first one, we'd type in the sine of 45. Again, we'd want to put that into its own set of parentheses. And then we'd want to, before I close that one, I'd want to tell the calculator that it's the reciprocal of the sine, which is the this -1 button that you have. So you'd hit this. Don't raise it to the -1 power. Hit this -1 button that you have on your calculator. Then close the parenthesis. Then, because it was actually cosecant squared, then you'd hit your squared button minus the 2 equals 0, and you'd find that it would work. I would take the time to plug this into your calculator because you want to make sure you know how to check for cosecants, secants, and cotangents. You have to use the sine, cosine, or tangent button, but then use the reciprocal button, which is this -1 power right here. And if you're having troubles with that, let me know and we can check them when you get back to class. Alright, so if we're going to solve this one, what I'm noticing about this problem is that I've got sines and cosines in it. But I do know that this is a Pythagorean identity, that it's the same as 1 minus the cosine squared. So that's a Pythagorean identity. I went to my sheet and I've found that that's the same identity. So I'm going to replace it so that my problem has all cosines in it. Now what I'm going to do is distributive property, 2 minus 2 cosine squared x. And then I'm going to move everything over to the same side of the problem so I can get it to be equal to 0. So those cancel out. Negative 2 cosine squared x minus cosine of x equals 0. And next thing I'm going to do is I'm going to factor this by taking out the greatest common factor. I'm going to make it be a negative cosine. So this would be then 2 cosine of x plus 1. And now I can set these both individually equal to 0. Negative cosine of x equals 0, and 2 cosine of x plus 1 equals 0. So algebraically, to solve this, I'd divide by negative 1. And here I would subtract 1 and divide by 2. So I'm looking for the cosine inverse of 0, so all the angles that have cosine of 0. And here I'm looking for the cosine inverse of negative 1/2. So I want to know all the angles that have a cosine of negative 1/2. So let's start with 0. All the angles that have a cosine of 0. Well, it looks like 0 degrees. I take that back. It doesn't look like 0 degrees. 0, that's the sine. I'm looking for a cosine of 0, so that'd be 90 degrees. 270. And that's it for the cosine of 0. For negative 1/2, it looks like 120 degrees. And 240 degrees. And that's it. So the way I'd want to give my answer here is to say 90 degrees plus n 360, 270 degrees plus n 360, 120 degrees plus n 360, and 240 degrees plus n 360. So that would be one answer. Now the other thing that I could do, if I didn't want to write it in degrees, I could write it in radians, and I could say pi over 2 plus n 2 pi, 2 pi over 3 plus n 2 pi. So use that one, this one, 4 pi over 3 plus n 2 pi, and finally the 270 degrees, which is 3 pi over 2 plus n 2 pi. So that would be how I would give my answer if it was in degree or radians. Take the time to plug this into your calculator to check. So in your calculator you would do 2 parenthesis sine of 90 degrees. Then you would want to square that and close the parenthesis. And you want to type that in separately, get an answer. And you would want to type in then 2 plus the cosine of 90 degrees, and you want them to check out. If they don't check out, this side getting an answer and this side getting an answer, and those being equal to each other, well then you know that that solution didn't work, and you need to go back and check your answers. Check your work here. Maybe you were looking at like I originally did, I looked at the sine value when I really wanted the cosine to be 0.